Hey there students, so welcome to part 4 of our differentiation review flashcards. We are going to be going over formulas 14 through 19 and we are focusing on inverse trigonometric functions on these review flashcards. Do visit our website on math.serve.com. For calculus videos, you can go under AP Calculus. Alright, let's take a look at formula number 14. It's read the derivative of the arcsine or the inverse sine of u. The derivative of the arcsine or inverse sine of u is 1 over the square root of 1 minus u squared du dx. Remember, du dx is a consequence of the chain rule. In this situation, we have a composite function where u is a function that the arcsine is being composed with. So when you differentiate the composite function, you differentiate the outer function, in this case arcsine first, times the derivative of the inner function, which is u, illustrated by du dx here. Now let's take a look at an example. The derivative of the arcsine of cosine x is, in this case, u is cosine x, so we're going to have 1 over the square root of 1 minus u squared. That is 1 over the square root of 1 minus cosine square x, since u is cosine, times du dx, or the derivative of cosine. The derivative of cosine is negative sine. We went over this in part 3. So if you multiply negative sine x by 1, in the numerator you end up with negative sine x over, for the final answer, the square root of 1 minus cosine square x. So this is an application of the differentiation rule for arcsine. Formula 15. This is read the derivative of the arc cosine or the inverse cosine of u. The derivative of the arcsine or inverse cosine of u is negative 1 over the square root of 1 minus u squared du dx. Remember, this is a composite function. That's why we have the du dx piece there. And this formula is very similar to the inverse sine function. The difference is that this is negative, or the opposite of the inverse or arcsine formula. Okay, so just introduce a negative to the formula we just went over, and you get the derivative of the arc cosine of u. An example, the derivative of the arc cosine of 3x squared. In this case, u is the inner function 3x squared, so the derivative of the outer function arc cosine is going to be negative 1 over the square root of 1 minus u squared. Since u is 3x squared, u squared is going to be 9x to the 4th as a result of squaring 3 and x squared. Now you have to multiply that derivative by the derivative of the inner function, du dx. In this case, u is 3x squared, and the derivative of 3x squared using the power rule is 6x. So that gets multiplied to the numerator. So your final answer is negative 6x over the square root of 1 minus 9x to the 4th. So that's an example of the arc cosine formula. All right, moving right along. This is read the derivative of the arctan or the inverse tangent of u, formula 16. The derivative of the arctan or inverse tan of u is 1 over 1 plus u squared du dx as a result of the chain rule. Now let's take a look at an example. The derivative of the arctan of sine 2x. In this situation, we have double composition happening here. The arctan is composed with sine, and sine is composed with the linear function 2x. So we're going to be applying the chain rule twice here. So when we're differentiating the outer function, arctan, we're going to have 1 over 1 plus u squared. U is sine 2x. So we're going to have 1 over sine, 1 plus sine 2x squared. Then we're going to differentiate the next function going inside, which is the sine function. The derivative of sine 2x. Now in sine 2x, 2x is going to be u because it's a composite function. Derivative of sine is cosine. So the derivative of sine is cosine 2x. And now we differentiate the innermost function, which is 2x. The derivative of 2x is 2. So there goes an example of the derivative of the arctan function and also the use of the chain rule. Next formula, formula 17. This is read the derivative of the arc cotangent or the inverse cotangent of u. The derivative of the arc cotangent or inverse cotangent of u is negative 1 over 1 plus u squared du dx. This formula is very similar to that of the inverse tan. The only difference is that this one has a negative. All right. Let's take a look at an example. The derivative of the arc cotangent of negative 3x. This is clearly a composite function. So you differentiate the outer function first, holding the inner fixed. So when we differentiate arc cotangent, calling this u, we're going to have negative 1 over 1 plus u squared. So it's going to be negative 1 over 1 plus negative 3x quantity squared, which simplifies into 9x squared. We're going to multiply that by the derivative of the inner function, du dx. The derivative of the negative 3x is negative 3 times the other negative 1 we had gives you positive 3. So your derivative is 3 plus 3 over 1 plus 9x squared. Next formula, formula number 18, is read the derivative of the arcsecant or inverse secant of u. The derivative of the arcsecant or inverse secant of u is 1 over the absolute value of the square root of u squared minus 1 du dx. Now this is a formula I always forget. I don't know why, but it's just something weird about it. But there goes the formula for the derivative of the arcsecant. Now let's take a look at an example. The derivative of 2 arcsecant x is equal to, you factor out the 2, using a constant multiple rule, you can factor out a constant from a derivative of a function. And then when you differentiate arcsecant of x, you have 1 over the absolute value of x, root x squared minus 1. Next formula is read the derivative of the arccosecant or the inverse secant of u. Inverse cosecant, sorry, of u. This is formula number 19. So the derivative of the arccosecant or inverse cosecant of u is negative 1 over this absolute value of u times the square root of u squared minus 1 du dx, a consequence of the application of the chain rule. Now in this situation, you notice that this formula is very similar to the previous formula, the formula for the derivative of the arcsecant. This is just the opposite of that formula. The only difference is that we have a negative here, and that of the secant has no negative. Everything else is identical. Now let's consider an example. The derivative of the arccosecant of pi x. Pi x is our inner function. We have a composite function here. So we're going to differentiate just the outer function. We'll have 1 over the absolute value of u times root u squared minus 1. In this case, u is pi x. So absolute value of u is absolute value of pi x. U squared is pi x quantity squared, which simplifies into pi squared x squared minus 1. du dx is the derivative of pi x. The derivative of pi x is pi. You multiply the pi by the numerator, which is 1. So you have negative pi over absolute value of pi x root pi squared x squared minus 1, an example of the application of the differentiation rule for cosecant, for inverse cosecant. So thanks so much for watching this presentation. Remember, you can write all these formulas down on index cards and then just go over them over and over again until you gain full mastery. Do subscribe to our channel for updates to other tutorials to assist you with your calculus course. Do post a comment to let us know what you think about this presentation. We'll appreciate it. And if you like this differentiation series, you can like it, favorite it, or share it with your friends. More clips can be found on math.serve.com. Thanks again for watching, and have a wonderful day.